All right, folks. So we are on Unit 2 of Math. This is actually Module 2 of Math here. Now, you should have this printed out for you. It should be there. So check your bag. If you haven't gotten it yet, ask. Either it's on the way still, or if you join late or something, or like there's some error, just get in contact with me. We'll make sure you get one. Okay. You don't need it. It's just nice to have. Okay. I'm gonna turn. You don't need to see me for this. I'm gonna focus on the work for this. Okay. Cool. Okay. So we are gonna be starting this out here. What is this? Is the 2025 key. Okay. I've fixed up my browser this time, so we shouldn't get the same issues. So we're going to start out here with broken line graphs. Now I'm just going to be trying to. Can I highlight? Do I have tools for that? I don't have a highlight tool, sadly. Sorry, I'm just figuring this one out myself. So all I have is a. Oh, that sucks. I guess I can do that. Bear with me. This has some cool new features, but also some ones that aren't so great. So okay, so starting out here, a that's two. So this is a graph that uses, we're going to start out with your couple. One's going to be a broken line graph. This uses points that are joined by something called legs, line segments. Again, we'll cover it all. This shows the information by plotting the values and joining them together, right? So it's literally plot the dots, connect the dots. It's a game of connect the dots in a graph. You use this to compare sets of data. And we can use multiple lines over the exact same graph. So, and this is good for showing trends, right? So, for example, I will show you an example of a broken line graph. Here is the Apple stock. Let's go to max. So in the last 5 years, this is, oh, what's the trend? Oh, it's going up a little bit, right? So that's what a trend is. If I were to show you, let's say, New York Times stock. I'm just using this as oh, it's trending downwards. Oh, never mind. No, it's not. What's a company that I think is failing? I have no idea. Okay, doesn't matter. Point being though, it shows a trend, right? So it's important you know what a trend is. It's just a general pattern that's emerging, right? If I were to show you a trend of Blockbuster, the place where you rented VHS and DVDs, that was obviously trending downwards. So we also have two new words: interpolate. You're going to see this occasionally, and extrapolate. Interpolate is where you estimate a value between two known things. Whereas extrapolate estimates a value beyond a range of nothing. So, for example, if I ask you to interpretate, let's imagine I give you this chart here, and I ask you to, here's a point, here's a point, here's my chart, and I'm like, hey, if this is how much, oh my gosh, here we go. If this is how much money you made, and this is how many hours you worked, how much money did you make if you worked this many hours? You're estimating it based on what you see here. Whereas if I were to be like, well, what if I were made this much? You're estimating beyond it. Like you're trying to figure out, well, how many hours would that be? So the key ideas here is that the scale and size of the graph can influence the way you interpret this data. We need to be changing the scale on the axis or changing the starting point of an axis. And I will talk about that later. But if you change those, you can change how a viewer misinterprets the graph. I'll show you a couple examples here. So you look at this graph really carefully here. This is showing the same information, but what's different here? Look at the left side. You can see the graph on the right starts with an axis of 0. And all of these are really close. There's some minor differences at the top if you look closely, but otherwise they look pretty similar. Whereas if I go and look at the left graph, I started out my axis at 950. And then, oh my God, people hate hamburgers. Oh my, no, they like hamburgers, pizza, and hot dogs the same for the most part, right? So you can mislead people with graphs. Another one here. Oh my God, Hilda is so much worse than Emily. No, this graph starts at 110. She's only about 20 points worse. Same thing. Oh my God, the unemployment years, George W. Bush was the worst thing ever for the economy. Well, no, they're really similar employment rates, right? There's like a 0.1% difference. It doesn't matter much. So that's what I mean here with misleading graphs. So we can change those axes to and change how the viewer interprets them. Even all of those graphs were done correctly, but we can influence your perception. So here are your steps for how to draw a graph, okay? Refer to them, put a star next to this, come back to it if you need to. Just make sure that you know how to draw a graph. It takes time, it takes practice. I mentioned this in module 1, but you can have a correct, well-done graph, and it's going to look different than someone else's. That's fine. It's a bit of an art form to it. It takes some time and practice to do. So starting out here, we are going to label the title of the graph, the horizontal axis, which is the x-axis, and the vertical axis, the y-axis, right? Horizontal is this one, and then going up and down is y. You want to decide the variables to display on the axes, right? This is hours and money. Those are variables. You want to decide on the scale, and this is the hard part right here. That's the very hard part. And so I'm going to give you a little bit of a tip here. To decide this, I'm going to make that bigger for you guys. To decide this, not the scale. What do you got to do? Well, you need to look at the biggest number on each axis. And I'll put this into examples, so it doesn't make sense to you, that's fine. You look at the biggest number of each axis. You're going to divide that number by the total number of squares. And then you're going to pick a slightly larger, easy number. Pick an easy number. For example here, if I tell you that, hey, on my x-axis, there's 875 data points, and there are 9 squares. Most of your charts here are going to have about 9 when you come to draw it yourself. Oh, okay, so 875, right? Divide this number by the total number of squares, 9 squares. Oh, so which one needs to be 97.2? Just round it up to 100. Just make each square 100. That's so much easier, isn't it? So you do that for both of them. The independent variable goes on the horizontal axis. It's almost always going to be time, right? If you don't remember what's the independent variable, what's the dependent variable, ask me or review your module 1.3 stuff. Your dependent variable, usually money, goes on the left side, or on the vertical axis, sorry. Okay, so let's go through an example here. This graph here shows the average snowfall in Regina, Saskatchewan by the month. What month has the highest average snowfall? Take a look at the graph. Think about that. Which month has the highest average snowfall? December, right? It's the highest on here. This represents snowfall. So it's clearly December. But remember, a lot of these questions are going to ask you multiple things. So it is obviously December, and it was 21 centimeters of snow that fell that month. During what 3 months is there no snowfall in Regina? Well, obviously it's June, July, and August, right? It shows you right there. June, July, August. And during which month is the average snowfall approximately twice as much as the average October snowfall? Well, so which month is twice as much as the average October? So October looks like we got about, what is that? 7? We got about 7. Um, so that means we're looking for something about like 13, 14, 15. Let's see. So not September, November. Yeah, that's about 14. Anything else close to there? Looks like February too. So you can have multiple. So it's clearly February and November had about twice as much. Okay, so I hope that makes a little bit of sense here on how those graphs work, how to read it. We primarily care about reading one right now. We'll learn how to draw one right now. So next one here is we have Jacob owns a small appliance repair company, and he's tracked the profits over 10 years. Hey, just like those stocks we looked at. And he's examining his data to see if there is a trend that he can tell. And so he's trying to see if he should figure out to increase the salary of his employees. So let's start out here. We're going to graph this. Now, you guys might have a chart here. If you don't, I'm going to show you how to make one. So let's make, this is going to be a little tricky on this, so I do apologize in advance. This is my first time making a graph with this software. I feel like it's going to be a pain in the ass. Okay, you know what? Let me try something. Okay, I've just changed some software here really quickly, so let's keep going. So you might have a picture on your screen, you might not. If you do, it might look something like this, where you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It should be a 14 by 14 square. So you might have those, you might not. I don't remember which version I printed out for you guys. But either way, if you don't have it, that's fine. I'm going to show you how to use it. So first thing I'm going to do is draw myself a line. You guys want to make yours straighter than mine? Oh, I can. How do I delete this? Okay, I can delete it. Nice. Okay. The first thing I'm going to do is draw myself a nice little line here. Make that black. And sorry, folks, I'm still learning how to use this tool here. This is a new one for me. So okay. This can just go away. Cancel. Okay, there we go. Sorry, folks. Okay, and a line. Sure. So next thing I'm going to do here is I'm going to, just like what I said up top with our instructions. In fact, I'll just show you on this screen, make your life easier. So I'm going to label the title of the graph, the horizontal and the vertical axis. So the title of the graph we're going to say is, I don't know, the company's net profits. We're going to say that this is our x-axis. This is our y-axis. Cool. Now I need to decide on the variables to display on the axes. What are my variables? The year and the profit. Think for a second. Which one of those goes on the x-axis, which is always the independent variable? Almost always going to be time, right? And money's usually on your y-axis, okay? So on the bottom, I have my year. On the y-axis, I have our profit in thousands of dollars. So next thing I need to do So I've done check, I've done check. Decide on the scale of each axis. Okay, so what does that mean? So on the x-axis here, well, there's 1, 2, 3, 4, 5, 6, 7, 8, and there's 9 data, sorry, 10 data points there. I need to use, if you're using that predetermined chart, well, there's 14 squares. Probably just go up by one, right? For this one here, I don't have that same luxury, so I'm just gonna try my best to like free ball it. So 1, 2, 3, 4. I'm making them about equal space. Again, if you're freehand in a graph, you're gonna be a little off. It's fine. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Next thing's going up. Same thing now. For you guys, if you're using that predetermined chart, you have 65 is your biggest number. And you're only going up 14. So, well, let's do 65 divided by 14 squares. What's an easy number that's slightly bigger than that? 5. You're going to go up by 5s on your chart. Now, for your chart, you're probably going to have these squares here, 5, 10, 15. That gets a bit annoying after a while, right? So why don't you can still go up where each square is 5, but only mark every 10. So I know this is still 25, right? They're scaled properly. I don't just put the 30 right here. That wouldn't work out very well. Oh, crap. Well, that didn't work out very well. There, doesn't exist. So 35, 40, 45, 50, 55, here's 60, 65, and we'll label 70, even though it doesn't go that high. So now it's a good graph, right? I've used up most of my space. I still need to label my year. I'm going to put 2000 over here. Here's 01, here's 02, here's 03, and so on and so forth. So you want to just think a little bit about your graph before you start doing it, is basically how it works. Here's 2006, 7, 8, 9, and here's 2010. Okay, so I've labeled my stuff here. I'm good to go. So now all I got to do, guys, is I just got to plot my points as best I can. Now, so at year 2000, I made $5. I'm going to make this blue. Can I make the size bigger? Another thing I can do? Circle. I can do a circle. So here, oh, that's not it. So at year 2000, I made $5 million. At 2001, I made 15. At 2002, I made about 18. Again, you're just freeballing as best you can. That looks like about 18. At 2003, I made 35. So 2003, go up to 35. At 2004, I made $40,000 profit. In 2005, I made 38, so about right here. 2006, I made 42, about right here. And then in 2007, oh, bad year, went down to 20. And so all I do is I just fill in all my points. 2008 was 58. And then 2009 was, of course, 65. Okay. So I now have a nice little chart here. Now all I got to do is, remember, broken line graph, all I got to do is plot. Where is it? I plot the values and I join them with line segments. It's connect the dots. Okay. So I'm just going to connect my dots. Do. You notice how I'm just going from like, just remember, I didn't just skip right to here. I'm going from 2007 to 2006 to 2005 to 2004 to 2003 to 2002, 1 and 0. And now I have myself a chart here. Again, it's done by hand, doesn't look that pretty. If you did this on with this page, it would look something like this. You also have some graph paper that was given to you. Feel free to use it if you want. I recommend use those for your questions though. And yeah, so this graph looks good to go now. So is there a general trend in this data? Think about it for a second. Is there a general trend in this data? Yeah. Over time, the company makes more money. Are there any exceptions, any outliers? In 2007, he lost money, but otherwise, he generally grows. Okay, so let's try out question 3 now. The following graph shows the growth rate of a bean plant that David planted in his vegetable garden, right? So you can see here, it's tracking the height and the week. So on week 1, it grew a little bit, grew a little bit, grew a lot, then the growth slowed down a bit. So that's what that graph is showing us. So David forgot to record the height of the bean plant in week 4. We need to use the graph to interpolate the height of the plant that week. Interpolate. What does that mean again? Interpolate means to estimate a value beyond its known values. So if it's 2000 and if it's week 4 here, well, we can figure out where it is on this line here using the information available to us. So let's think about it. Let's go to, if it's week 4, let's go to week 4 and let's follow it up, right? Oh, it looks like it's about 22. It looks like it's about 22 or 23 centimeters tall in week 4, right? Again, we don't know for sure. We're interpolating. We're doing an estimated guess, an educated guess, sorry. Whereas in question B, well, what might be the height of the plant in week 12? Well, what happened the last few weeks? This is extrapolating. We are extrapolating this. We're estimating the value beyond the known range. We don't know what it's going to look like in week 12 for sure. But we can probably guess that based on the trajectory of this line, it's probably going to be about the same. So it looks like it'll be about 39 or 40. So we want to write a statement describing trends in the beans plant's growth from week 0 to week 11. So like what happened to the plant throughout those weeks? Just a summary. Well, it looks like it grew It grew rapidly for the first 5 weeks, and then growth slowed down over time until it's stopped. It seems like it's stopped growing, right? Okay. Question 4. So again, I'm not sure if you have a chart or not on yours. We'll figure it out. Brett is a real estate agent and is comparing the average list prices of houses in Vancouver to those in Regina from 2006 to 2010. Now, for those of you who do have a printed out booklet with the chart in it, I'll show you what that looks like in a second. For those of you who don't, we're just going to draw it freehand. Again, I apologize when I'm recording this video. I don't know which one I gave you. So first thing I'm going to do is I'm just going to actually draw myself a nice little graph here to use. So the next thing I need to do is I need to follow my normal graph steps here. And I'm not going to do this. I'm not going to just go up and down, up and down, up and down each time. I'm just going to do it, follow the steps. You can go back to your second page if you want. The first thing I need to do is label the title, right? It's house prices in Regina and Vancouver. That's the title. The horizontal axis, this is X. The vertical axis, this is Y. Now I need to decide on the scale of each axis. So just like before, if you have that pre-made chart, you have 14 slots available to you. What's my biggest number in money? 685,000. Divided by 14. What's a slightly bigger number than that? About 50,000, right? You can go up by 50,000 if you want. That seems like a really easy number. You could go up by 75,000, but again, that makes it a little bit harder to guesstimate. Easy numbers are good. Okay, so red. Now, what's different from this graph and question 2? There are 2 things to plot. We're going to have 2 lines. I'm going to make Regina red. I'm going to make Vancouver green. So I've decided on the scale as well. I'm going to go up by 50,000s on the vertical axis, and then down at the horizontal, it's just 5 years. So we'll say this is 2006, 2007, 2008, 2009, 2010. So those have spaced it out. I didn't go boom, 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 boom. I'll start. No, space them out. It's fine if it's like 1 year takes 3 squares. So next thing I'm going to do is I'm going to go up here. So here's 50, here's 100. I'm just going to put 100, just 100. And I'll write its thousands later. 150, 200, 250, 300, 350, 400, 450, 500, 550, 600, 650, $700,000. So let's label our axes. This is thousands of dollars, right? So $500,000. This here is year. Should probably label it too. 06, 07, 08, 09, and 10. Now, I have intentionally made a mistake on this graph, and I want you to see if you can find it. The mistake is I'm starting 2006 out here. It should be over here, right? This should be 2006. Here's 07, here's 08, here's 9, and then here's 2010. So really easy to make mistakes like that. Again, if you were to do that on like a test or something, like that'd be generally fine, like if you've done everything else right. So cool. Now what I need to do is I need to plot my graph, right? And so I'm going to start with Regina. I'm going to keep it red here. Let's go with our circles. So let's start out here. So in 2006, average Regina house was 132,000, something like there. In 2007, it was 166. Again, I'm just guesstimating. Then in 2008, it was 230,000, about right here. 2009, it was 230,000 again, exact same. 2010, it was 232,000, so about the same, right? Right, so you just connect your dots, connect the dots, connect the dots, connect the dots. Cool. Now let's do the same for our blue one. So in Vancouver, it starts at 571, which is about right here. 2007, almost $600,000. We'll put that right about here. 2008 looks like it goes to about 592,000, so about the same. 2009, it's 665, so it's gone up a little bit. Ignore my mouse click there. Put it there. And then 2010, it went all the way up to $685,000. So about right here. Right? And then you just connect your dots. I'm not done. Oh, sorry. I said green. I'll do blue here. My bad. So there's something to note here. If I didn't use different colors here and I removed this graph or this table of data, if I got rid of this, how would you know which line's which? You need to either do a legend, right? This is Vancouver in blue. Or here's Regina in red. This counts as a legend too. So you can do something like that. Or, and it's a good habit to do both, you can label it Vancouver. Ideally make that blue and Regina. So having multiple colors of pens here are going to be really helpful. I'll show you some other ways you can do it if you only have one color or pencil. But this is what it looks like. And again, this is what it would look like on the other side here if you had the other chart. So what can we discover from these tables about these two cities? Well, obviously, Vancouver is more expensive. Regina prices stabilized. Vancouver prices continued to increase. So even though Regina's houses stabilized, right? 230, 230, 230. Regina's kept, or sorry, Vancouver's kept going up. So what can we tell more from the graph? Can we tell more from the graph rather than from the table? That Vancouver has more expensive houses. All right, and question 5 here. So the graph below indicates the approximate cost of a metal, of a sheet metal per ton over a period of time. Sorry, I had to do something with my computer there. So that's this chart here. So what happened to the price of sheet metal over time? So if we're looking at this graph, what happened to it? It goes up and down, up and down, up and down, up and down, up and down. We have a word for that. Ooh, not that. There we go. It fluctuated. So it fluctuated. So what are the scale and the starting point of the vertical axis? Now, does anyone see this? The vertical axis, right? That is this line right here. I'm going to zoom in. What did it do? It went immediately from 1 all the way to 500. But then this one's not 1,000. This isn't 1,500. This isn't 2,000. So you're noticing this little squiggly line here. So this is something that tells us, the people with the graph, remember all those misinterpreted graphs I showed you earlier? That's what they did. They started up here because they had no data below $500. So otherwise, the graph would look something like this. Well, they don't want that. So they changed the starting point of it. So what's the scale of it? The scale, it's not 50. It's 25, right? This goes up 25. This goes up to 25. So the scale is $25, not 50. And the starting point is $500. So next year, we want to redraw this graph, starting the vertical axis at 0 and using the same scale. Now, I'm just going to show you what that looks like. I'm going to get you guys to do it at this point. I want you to practice it. use the information at the top on page 2. At this point, you should be able to draw a basic graph like this. So start drawing it. I'm going to show you what a completed one looks like in 3, 2, 1. So here's the completed graph here. And as you can see, it's the same scale, right? It's going up like 25s and 50s and stuff. I actually couldn't go up by 50. I didn't have enough space. I had to go up by 25. I had to go up by 50. But this is what the actual graph looks like here. Much less pronounced, right? So this spike doesn't seem that big of a deal now. It's like, that's only up like $100. Who cares? So what does this new graph show about the fluctuation in prices? The fluctuations are less severe than anticipated. That's simple. So what you should be doing now is you should be able to practice all of this, and you should be able to complete all of it up until question, I believe it's 10? No. All the way up until question 12. So complete all practice questions from 1 to 12. Complete and submit the review questions. And you can go to this assignment on the LMS. I'm not going to ask you to do every single one, but I'm going to ask you to submit 1 or 2 really good examples of a graph. There will be more details on the LMS. Okay. You need to be good at drawing graphs. It is time consuming. It is tedious. It is a necessary skill for this class. You're going to be drawing and reading a hell of a lot of graphs. So if you are still struggling after watching this video, ask me for help, and we will walk through it together.